Open your book to page 322. This lesson is on the equation of a plane. And this is going to be very similar to the two-dimensional. So I'm going to put side by side so you can have something to compare with. So 2D and 3D. So in 2D you got two equations, right? You have ax plus by plus c equal to 0. And so 2D, this is going to be a line, right? This is equation of a line. Whereas 3D, you're going to have the equation of a plane. And it's going to look very similar. You're going to have ax plus by plus cz plus d equal to 0. Okay. Now in two-dimensional, the a and the b, this will give you the slope, right? And this is the intercept. The slope is a direction, whereas the intercept is the location. So you're going to do so. It's a similar things for the plane. Okay. So A, B, and C. Instead of the slope, you're going to get normal. Normal is like a perpendicular direction where it's facing. Okay, so this is just like the slope. So the normal is the direction that the plane is facing. Okay, and this is the intercept. This gives you the location. So they are the same thing. Okay. So let's go to example 1. So in example 1, it says what the equation of the plane containing the P1 is at 4, -3, 2, and it's perpendicular to the vector normal. So this is what you have. Okay? You have a plane, and over here it's perpendicular to the normal. Okay? Again, normal is like your direction. So in a similar way, they will give you a point. Okay, you got x, y, right? Then they give you the slope. Okay. So this is like the same situation. The point, and you have the normal is like your slope. So point slope, you're going to use point slope form, right? But over here, again, the normal is given to you as 2i minus 3j plus 5k. So in this case, it's easier than the two-dimensional. So to write the equation, because the normal is the direction the plane is facing, so all you do, you start with, so this would be your 2x, right, minus 3y plus 5z plus d equal to 0, right? That's your equation, right? Ax, by, cz, d. Okay. And then from here to find d, right? Just like over here, the slope. From the slope, you can get your point slope form. You're going to get ax plus by plus c equal to 0. And then you substitute the x1, y1 into the equation to get c, right? So in the same way, okay, you can go off to the side. So I'm going to do it on the side over here so I don't interfere with my major steps. So since this plane contains the point P1, right? So this P1 is in this plane, so you need to put this point into the equation to get the D. Okay? Because what happens is that this one has many different possible planes, right? For example, you can have a plane over here, and you can have the one below it, right? Right? You can have all these have the same normal, right? Right? So the point will decide which one is it, right? So again, that's why I said this is the location. It tells you is it this one, or this one, right? So this will lock into which one, right? Because you got all infinite number of possible planes that were facing the same direction. So again, so substitute a point into here to get D. So you're going to get 2 parentheses minus 3 parentheses plus 5 parentheses plus d equal to 0, right? And again, the point that you want to have is this one here. So you're going to get 4, right? Negative 3, and 2. So you work it out. So 8 plus 9 plus 10 plus d equal to 0. So 27 plus d equal to 0. Minus 27 minus 27. So d equal to negative 27. And the reason I do it off to the side, so if you do all this over here, by the time you get to here, some of you are going to lose track of what you're doing. So do it off to the side so you know that you're getting the d. So once you find d, you put it back in here. So you got 2x minus 3y plus 5z minus 27 equal to 0. Okay, and that's the equation for the plane. Again, just like the point slope, right? Same idea.